Okay, now we're going to talk about trapezoids. And trapezoids are quadrilaterals with one pair of opposite sides that are parallel. I'm going to go ahead and name this trapezoid so we can talk about its parts. The parallel sides of the trapezoid are called the bases. So this could be base 1 and this would be base 2. It doesn't matter which one's base 1 and base 2. Just notice that you have two different size bases. They're parallel to each other, so let me put these little parallel symbols on those two sides so we know that they're parallel. Alright, then we know the non-parallel sides are known as the legs. If the legs were congruent, we would call this an isosceles trapezoid. Obviously in this picture the legs are not congruent, so this is just a general trapezoid. Okay, there's other parts that we need to be aware of. On either side, on either end of a base, you find a pair of base angles. So angle B and angle C are base angles. But like the isosceles triangle has one pair of base angles. Because a trapezoid has two bases, it has two pairs of base angles. So angle A and angle D are base angles also. Now we're going to be comparing in a minute the angles that are not base angles but are consecutive. So for example, angle A and angle B. These two are not base angles, even though they're consecutive, because they're not on either end of the same base. But they are on either end of the same leg. So I like to refer to these as leg angles. It's not a real term, it's just an easier way to remember this kind of angles. They're just, you'll see what they are in just a second. There's also D and C, angle D and angle C. Also, I like to refer to as leg angles. Okay, so what properties do those leg angles have? Well, let's look at a pair. If I look at that base parallel to base BC, and then I've got this leg right here, and then I have angle A compared to angle B. Okay, those two, well, like I said, I like to call them leg angles. I'm going to take this and move it over, put it over here. You might right away notice that you already know the relationship between those angles. Okay, these angles right here are just same side interiors. So those leg angles are actually same side interior angles. So we would say that those angles are supplementary. Okay, so these leg angles are supplementary. Alright, so that means that the measure of angle A added to the measure of angle B equals 180. That's how you would set up a problem with those two angles. And we have another pair of leg angles, D and C, so you could also say the measure of angle D plus the measure of angle C equals 180 degrees. Alright, that's the angle property that goes with the general parallelogram, trapezoid. Next we have the mid-segment of a trapezoid. The mid-segment is a segment that connects the midpoints of the legs. So let's say I find the midpoint of this leg, so I know those two pieces are the same. I find the midpoint of this leg, so those two pieces are the same because that's the midpoint. And then I connect them. What I've just made is what we call the mid-segment. There are two properties associated with with the mid-segment. The first one has to do with its length. Since it's halfway between base 1 and base 2, it's actually the average of those two lengths. So the length of the mid-segment is equal to the average of the bases. So add base 1 to base 2 and divide by 2. The second property is that it actually ends up being parallel to the bases. So the mid-segment, so this is property 1, this is property 2. The mid-segment is parallel to the bases. Okay, last we have the isosceles trapezoid. So the isosceles trapezoid is a trapezoid where the legs are congruent to each other. So we still have a base and a base that are parallel to each other, but then the legs are congruent to each other. So it's kind of like an isosceles triangle where the top just got cut off. Okay, so we got this isosceles triangle right here. And if we just chop the top of that isosceles triangle off, you have an isosceles trapezoid. So you would expect that the base angles property that you have for isosceles triangle would also be applied to an isosceles trapezoid, and that is true. These base angles down here, okay, let's go back to when it was a triangle. These base angles right here, we would expect to be congruent in the isosceles triangle. If I just chop the top off, of course they're still going to be congruent. But it's also the case that the other pair of base angles are congruent to each other. So the base angles that are up on either end of the first base are also congruent. So angle A is also congruent to angle B. All right, so with an isosceles trapezoid, we know that base angles are congruent. So if you had a problem with one of those angles, you could set it up saying the measure of angle A equals the measure of angle B. You can also say the measure of angle D is equal to the measure, of angle C. Okay, the last property about trapezoids that I'm going to tell you about is the isosceles trapezoid diagonals. Because those legs are congruent, it kind of evens this up a little bit. And the isosceles trapezoid only, not a general trapezoid, this is only true for the isosceles trapezoid, has diagonals that are congruent. So if I was going to do a problem involving those diagonals, I would say AC is the same length as BD, and that's how I would set up the equation. Okay, the next video we're going to go through the apply it problems to get you ready to do your homework.